Welcome everybody to the 2 p.m. Eastern session where Davlet, who is the CTO of CloudGenie, is going to present how to safely deploy AI agents that write and manage your IaC. Again, chat is open on the right. Drop some questions in there and we'll have a Q&A session at the end. Davlet, over to you.
Yeah, thank you. Thank you, Gareth, for introduction. And it's great to be here. I've been following almost all the sessions up to now. So I think this session will fit perfectly into the theme of this conference has been so far. There's been a lot of talk about AI and challenges around adopting AI, right? So I think this is where we probably come with a lot of questions. Okay, now this technology is taking over as tsunami. What do we do? What concretely can we do about it? So today we will hopefully go away with some practical understanding of, well, what does it take to actually run AI agents in production and how to run them safely. And more than that, you will actually get away with ready-made tools that you could also start using. That same principles that we will discuss today, that already built in. Before that, maybe I can just do a very short introduction of myself. Let me just, I will put it later as well, but very quickly, I'm Davlet. I'm a founder of CloudGenie. We've been deploying AI agents in production for infrastructure for the past 2 years. And a lot of the content of this talk is the essence of this experience and all the problems that we hit, all the challenges and the solutions that we came to overcome those. Previously, worked at Microsoft and been a startup CTO, and the infrastructure in general and DevOps been a topic that is important for me personally, because as a technology person, I always felt the need to make product team go as fast as possible. And now as software teams go faster and faster, we can end up in a situation where platform teams become a bottleneck. And there is a good reason for this, not because platform teams are less skilled than software engineers, but because the price of mistake is much, much higher. So here is where the problem is, right? An error in your web code or maybe application code can lead to loss of some functionality. An error at the infrastructure level is potentially disastrous. Your users cannot access your services, you lose proprietary data. This is trouble, and we definitely want to avoid it. However, we cannot ignore that technology that is definitely accelerating everything. So we are not able to ignore it. So we need to adopt it, but we need to know how. And to solve this problem, we shared a guide that I will also put a link later on that you all can see. But essentially, everything I will be talking about is based on this guide. So we will cover the thinking that went into creating it, and you will understand hopefully as well why there is certain decisions were made and certain practices that are necessary to adopt AI for infrastructure. And we will start with those principles. And this is hopefully not going to be very controversial, but there is one thing that I think maybe could be not in track with some other speakers, where there is a little bit of discourse around, is IaC necessary in post-AI world, so to speak? isn't it better to bypass it and go straight to deployments? And from our experience of running AI agents in production for the past 2 years, I do believe that IaC is absolutely necessary, and there are good reasons for this. Architectural reasons behind the LLMs, which are non-deterministic, and you are not able to trust them to come up to the same decision every time you want to ask it to do the same job. So it is not what it's made for. And you do not want this kind of variability. You want to make sure that your decisions that you want to be repeatable, they are done exactly the same way, and they can also be reversed the same way. So for this reason, I do believe IaC will stay, not maybe in the same format or not in the same vision as we have them today, but definitely some sort of tracking of those changes. So now that we got that out of the way, you will understand that a lot of other decisions around that. So everything that we build around revolves around some sort of IaC. It could be Terraform, it could be Azure Bicep, it could be Pulumi. It actually doesn't matter. For agents, what's important is that they can rely on something that is repeatable. However, what agents allow us is something that was not possible ever before, is making those small tweaks or that add this kind of configurability that was not possible before with just, let's say, templates or scripting, right? You will, by definition, will get the same answer every time. However, the realities of life change quite quickly. And to be able to do those creative changes is what agents allow to do fast. So this is why we never allow agents to run deployments directly. It always have to be gated through certain processes. And we treat them as a team member, right? This is another sort of good mental model to think about it. They are your team members, and they're not special. They should not bypass your normal guardrails, your normal checks. They should have only privileges that they need to do the work. Just like someone compared them to intern, I could compare them to junior engineer, maybe even good. The level of engineering capacity is definitely increasing, but they still don't need to have the full power as all of your engineers or admins do. So we need to provide them with enough information and enough permissions to do the job, but not more than that. And we need to be able to understand what do they do, track every actions that they do, so that we can also understand and learn when something goes wrong to understand what went wrong. And for these reasons, it is almost impossible today to run the agents in production, because you, as practitioners, most solutions today offer either you go and buy Cloud Code subscription to your organization, and everyone has to deal with their own problems and learning how to set up those agents. Or you have maybe more guardrailed and more safe solutions that are offered by hyperscalers. However, they are so limited and often not as good in the quality, to the point the quality of the work they can do is very limited. And that's not just our words, it's observations of our own customers. So this is where we felt that there was a gap that we needed to bridge. So there needs to be a space for agents to live, where you can set up policies, where you can set up runtime, track the changes, and observe what they do. And then for change control, you already have your GitOps. So this time, this part is quite okay to integrate into. However, with policies as well. But however, you need to be able to integrate your agents to those in a good way. Run agents in a runtime in the sandbox environments where they are not able to get more access than they're supposed to, where they able to do the work, but without affecting larger infrastructure. So this is essentially why it's important to have agentic runtime and sandbox, because if you run your agents on your local machines, on your desktops, essentially it's just a matter of time before they get out of the bounds of what you ask them to do, and they will try to get access to the credentials that you might have forgot about in your .ssh files or any other places, or your environmental variables. And then you also you basically need isolation for agents to run safely. And that also speaks about the context, right? How can you give agents enough context to be useful? However, every time setting up the GitHub repos, the cloud credentials, every time setting up all the documentation that it needs to do work, this is also produces quite a lot of risk, because you also need to do it correct every time. So let me pause the presentation here. Yes, so the credentials, and we will get back to it. Let me pause here, and then I can show you what we. This is a new announcement. This is OpenGenie, the Open Agent Runtime, that solves a lot of those problems, and you can run it yourself, absolutely. Right? The sandbox, tool execution, durable sessions, replayable history, audits. So now you have a place where you can run your agents, give them access to the data you care about, give permissions in single place, and then your end users, they don't have to worry about all these complications. They just want to get benefit from AI. So let me show you how that might look like in this example. Maybe I can do this. So this is the open source version of CloudGenie, the OpenGenie agent, which is built on the same principles that we built with CloudGenie, but without all the specific stuff that we needed to do to support particular workflows or particular customers. The idea behind this open platform is basically you can develop any kind of workflow, any kind of solution that you want to do with agents in a safe way. So if we follow the guide, right, we need an agentic runtime. So for these purposes, we use OpenAI SDK. You can choose any kind of runtime you want. It could be Cloud, it could be one of the hyperscalers running on Azure Foundry or Agent Core released by AWS. Or you can build your own if you want to use LLM models by yourself. So you need to run it. You need LLM essentially with access to the tool calls, with access to the models, and you need to provide it with certain access. So that could be your Git repos, that could be your cloud accounts, and then you provide it with documents, such as it could be internal documentation, it could be your wikis, any kind of proprietary data that is very useful for agent if you want to run them in production, if you want them to understand the rules and custom policies that your organization have set up. And from there, we can start doing very interesting work. We can, again, connect to different kind of MCPs. We can enable skills, and that is all done in centralized manner. So, and as end user, all I care about is, okay, run check of checks and propose a fix for some problem. On there, I have a prompt suggestion, right? So this will run for a while, and I can just show maybe history where agent already did this work. It inspected the repository that I connected to it. In this case, it was AWS test. It ran the check of checks. It found some problems in it, and using the Terraform style guidance, the skills. Shout out to Anton Bambenko with his Terraform skills as well. And then at the end, we would get a ready-made PR that would fix one of the problems, right? And then we can review this and check that, did it do the right changes? And did it understand the problem well enough? And this is a very simple example, but it already shows you the power of this workflow. And you can run your typical pipeline checks on this code and even integrate it back into the agent. So that an agent can read the errors that you get from your pipelines and then continuously operate on those until those are completely fixed. So that produces a loop, agentic loop, where agent has access to the data, the repo context, to the cloud. It has access to the tools to run for security, for cost analysis. It has the right access to the additional guardrails, pipelines, checks, and using all of those, it will run continuously until it gets the job done. And that allows you to run long-running sessions safely, because you also limited the access to the agents. You forced it to run only through PRs. But then those long-running sessions will produce most likely near 100% code in most of the cases, right? And then it still allows place for the reviews. So this was an example of such sort of what is possible to build. So let me get back to the presentation. So yes, so those 4 planes, agent runtime is important. Credentials is, again, the only way I see to prevent credentials from being leaked is never allow agents to even have a chance at getting credentials they're not supposed to have. So that means we essentially don't have a choice by not giving end users to run their own agents. It needs to be quite centralized, and then we need to protect those in existing solutions. Could be Azure Key Vault or HashiCorp Vault, where agents will request credentials that it needs to do for the job, and just for this time being, right? Time bound, scope bound. And then we already talked about why PR reviews are so important, because it creates this contract between humans and agents, where you also have all your existing in setup, all the work you've done to make your infrastructure robust. You actually benefit from it. Your agents benefit from it. And of course, that creates another audit trail in addition to the agentic audits. You also can set up revert paths. There is just, there is no good reason to avoid this. And that presents a new sort of ability for us to potentially set up how to trust agents more, right? And start giving them more and more autonomy, potentially. In the beginning, when you start using agents, it is natural to start reviewing every line of the code and maybe treat it more of as a Copilot or IntelliSense. However, if we are truly to benefit from this technology, we want to get to those long-running sessions. And the way we think about it is usually it's good to think about some workflows that we know of that are very repeatable, very bounded, and very easy to test and reproduce. So those can be done completely autonomously, because then we can scope them very tightly. We can test them, we can run the validation checks, and essentially let the agents fully own this kind of work. So I already showed you this a small example with check of checks and security checks. You can connect to your security providers and do the similar thing. What other possible use cases for this is, for example, import of resources from cloud to infrastructure as a code. This been a topic that's always relevant for most organizations that had their infrastructure long enough, right? Not everything is tracked in the IaC. However, if our model to run everything through IaC is correct, then we need to make sure that everything is indeed in IaC so that we can actually make changes to the whole cloud. So we need to make sure that this job is super easy to do. So I can show already in our production version of CloudGenie how that loop might work using all the guardrails that I've already described. So let me share my screen again. And here is an example of CloudGenie agent where we scan the real cloud infrastructure. In this case, it's Azure. And then we scan the infrastructure as a code. And now we can see run the gaps in which parts of the system are actually in infrastructure as a code and which we can bring into infrastructure as a code. So there is still quite a bit of those. And maybe I want to take a look at as a graph and choose some example infrastructure and bring them into infrastructure as a code. So here I can also give it guidance, maybe use internal models, could be, or use Azure verified models, and then the agent will adjust based on your prompt. If you don't provide any prompt, it will base it on context of your infra and your documentation. So again, this will run for a while because it will take a few loops to get it right. But this is essentially the result, right? Where agent will try to understand the context of the infrastructure, what's in the cloud, what's in the code, and create, at the end of this, we'll create, we'll create a pull request. Let me share this one with all the necessary information for me. It will run the pipelines checks that we already have set up for it until it's completely confident that there is no diff between what's in the cloud and what what it was able to generate, and it will use exactly the same standards that we already enforced in our infrastructure. So this is an example, and what is the other sort of similar loops that we discovered that is possible to do already, in addition to import, is maybe detecting the drift and auto-remediating it, detecting security problems, and again remediating them until there is no security alerts firing on those issues, and potentially getting into the more complex scenarios where agents using the data from different sources identify potential savings, where if it has the right data about the cost of the resources, usage data, then can be helpful to detect where you are potentially running orphaned resources or low usage and right sizing potential. So all this information you can also find in the open source guide if you want to try to build your own workflows that you see in your own work, right? And what OpenGenie allows you is that all the boring stuff, all the piping, how to run agents in the cloud and set up those permissions levels correctly is already solved, so that you can adopt it to your need and to your specific use case easily. So I think I will stop here, and maybe we will have more time for the questions. And
Yep, we can start with some of the questions that have the most upvotes. We'll start with this one. It says, when I run an agent on my computer, it uses my SSH key for GitHub, which has admin permissions. How can I limit an agent's GitHub actions when it runs from my computer?
This is exactly the problem, right, I'm talking about. When you run it from your computer, you actually don't have that many options to limit it. I see there are some people have like hacks where they try to protect certain folders, but it's always going to be not ideal, because you want to start with minimal permissions first, right, or minimal impact first, and rather add to it rather than try to subtract from everything. So the way we solve it is creating a separate, for example, a GitHub app that has limited permissions on your repo, and then your agent will run through this GitHub app. So this is will ensure that that you can control what the agents can do just by controlling the permissions that this GitHub app has. For example, if it cannot merge, and then you will know that agent will never merge, even if you try really hard to avoid it, or if you prompted it in a way that is ambiguous. And this is essentially the same problem that we want to avoid with prompting, where by saying, okay, I want this S3 bucket removed, you don't want the agent thinking, I can just remove it from directly from the cloud account and run some CLI. That is probably dangerous. What you would want to do it probably is that it removes it from your Terraform definition, and then you can decide if that's exactly what you can verify if that was correct storage bucket and correct resources that are getting removed. But they're not actually getting removed. It's only going to be removed when you merge those PRs and run your apply pipelines. So for these reasons, we really not recommend to run infrastructure agents, at least, on your computers and rather refer to the cloud agents, cloud hosted agents or sandboxed agents. And if you want to run it on your computer, then you need to run it inside Docker. And as I said, to give access to this GitHub app or some credential that has limited permissions and not your own permissions.
Okay. Next, it says that there's a lot of talks about strict guardrails and observability, token limits, etc., but only a few people know what to do and what to implement. Do you have any practical examples, such as AI, MCP, gateways, or anything similar?
Yeah, no, I completely agree. It's still a new field, so people are still figuring out. I think you will find a lot of useful stuff in the infrastructure agents guide. We talk a lot about that. Speaking of MCP specifically, it's also interesting topic because this is another case where we think centralization is important. You want to be able to control how to enable MCPs from one place, and ideally the person that understands them. For the reason that you've already heard maybe that it's another attack vector for if someone, let's say, can include malicious intent into MCPs and agents start using those or access the servers that they're not supposed to use. So this is another reason why letting, let's say, end users to define their own, enable any kind of MCPs, any kind of permissions on their local machines is a nightmare for any CISO. So this question will be covered more in the infrastructure agents guide. But this is one example, right? We believe it should be centralized and basically verified. Every MCP needs to be verified before it's enabled for end user.
Another one is what guardrail can be added to the agent and how do we make sure the agent won't hallucinate?
Yeah, so the hallucination is essentially the whole reason why we started with the CloudGenie. And I think there's going to be less of those as capabilities of agents are increasing, and we experience that. But that's why you always want to verify what agents does with hard data, right? So in that case, the output of your Terraform plan, the checks of your security guardrails and OPA checks and check of checks and so on. So this is where we insist that every engineering that has already been done so far is actually very useful for agents, and that would allow them to, even if they hallucinate, you kind of need to expect that it will hallucinate. So what can we do? What kind of boundaries and checks and validations can we add around it so that we can minimize and protect against it?
Let's see. We also have, so yes, all the presentations and recordings and everything will be shared on demand and also on our YouTube channel.
Yeah.
And then we also have, maybe, I'm not sure if we have 50 a minute. I don't know if I think that's it for questions.
Yeah, I think as a last thing, I wanted to share as well that there is a lot of uncertainty about engineering as a whole these days, and the value of being a good engineer as well as AI systems become better and better. I do believe, I hope what it leaves you with after this talk is that you actually need to be a very good engineer and architect to be able to guide and set up agents in a way that they're actually usable in productions, because all the good systems that you put in place, they require you understanding them, understanding the boundaries, understanding the blast radius. And what agents allows us to do is to remove the menial and mundane work and focus on actually what is important. So yeah, I think that my last words for this.
Amazing. Thank you so much. We are a little over time. Yeah, I hope everybody enjoys the rest of the sessions for the day, and thank you so much.
Thank you.